We've all seen it in the movies, right? A doctor leans in, says count backwards from 10, and before you can even get to 8, poof, you're out. You wake up, the surgery's over, and it feels like literally no time has passed. We totally take it for granted. But what is actually going on in your brain when the lights go out?
So, is it just a really, really deep nap? I mean, that's what it feels like. But the answer is a hard no. What you're experiencing is, well, it's something way more complex and honestly, kind of mind blowing.
Here's the deal. General anesthesia isn't sleep. It's actually a carefully managed, totally reversible coma. Yeah, a coma. So for this, we're going to focus on that specific type, the one that makes you completely unaware, to really understand how science makes this temporary oblivion not only possible, but incredibly safe. All right, first things first, let's just completely tear down that biggest myth right from the start. Anesthesia and sleep, they are fundamentally different states of being, not even in the same ballpark. See, anesthesia isn't one single magic bullet. It's this delicate scientific cocktail of different drugs, and each one has a very specific job to do. And together, their mission is to flip 3 critical off switches inside your brain: your consciousness, your memory, and your ability to feel pain. So let's get into the good stuff. Let's break down exactly how this chemical cocktail targets those 3 switches to pull off the entire anesthetic state. To really get this, we need a super quick look at the brain's basic communication system. It's always buzzing with these tiny messengers called neurotransmitters. Now, some of them are excitatory. They're the ones shouting, go, 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 telling your neurons to fire. But others are inhibitory. They're the ones that gently whisper, stop. Anesthesia is all about turning up the volume on that whisper until it's a roar. So this whole process has 3 main goals. First, you got to turn off awareness. Second, you have to block any new memories from forming, super important. And third, pretty obviously, you need to stop any sensation of pain. Let's look at how each one of those switches gets flipped. Okay, switch number 1, consciousness. This is the big one. Most general anesthetics, like the famous one propofol, work by targeting your brain's main stop system, these things called GABA receptors. Think of these receptors as the main stop button for all your neurons. The drug comes in and basically supercharges them, holding that stop button down so hard that communication between brain cells just grinds to a halt. And that's how you lose consciousness. But just hitting stop isn't enough. Turning off the go signals is just as important. For switch number 2, amnesia. Other drugs in the cocktail go after the NMDA receptors. These guys get activated by the brain's main go signal. So by blocking them, it's like you're unplugging the phone line completely. No new signals can get through, which means no new memories can be formed. No memory, no trauma. It's brilliant. And that brings us to the final critical switch, analgesia, or, pain relief. It's not enough to just turn off the brain's awareness. You have to physically stop the pain signals themselves. This is where powerful meds, often opioids, come in. They create a roadblock in your spinal cord and your brain, stopping those signals in their tracks before they can ever be perceived. So you've got consciousness, amnesia, and analgesia. All 3 switches are flipped. But managing this state, wow, that is an incredibly high-stakes balancing act. And that brings us to the most important person in that room, besides the surgeon, of course. This entire complex chemical dance is orchestrated and managed second by second by the anesthesiologist. This is a highly specialized doctor who is, for the whole procedure, your personal human safety net. And they do this through constant, vigilant monitoring of your vital signs. I mean, they're tracking your heart rate and blood pressure to make sure your heart is stable. They're watching your oxygen levels like a hawk. They're even measuring the carbon dioxide you breathe out to make sure you're breathing effectively. And get this, they often use an EEG to actually watch your brain's electrical activity just to make sure you stay at that perfect depth of unconsciousness. So here's the crucial part. They are constantly making these tiny adjustments to the drugs, fighting to keep you in that perfect, reversible sweet spot. Deep enough so the surgery can happen without any pain or awareness, but not so deep that it becomes dangerous to your body. Because these drugs can slow down things like breathing and circulation, the anesthesiologist is basically managing your entire body's physiology minute by minute. You have to remember this. They are not just putting you to sleep, they are actively keeping you alive. So, after all that, how do you even come back from this carefully controlled oblivion? Well, the process of waking up is just as precise as the process of going under.
The return trip is actually surprisingly straightforward. First, they just stop giving you the drugs. See, these drugs are designed to be short-acting, so your body gets to work breaking them down right away. As those drug levels fall, the brain's stop buttons are released, and normal communication just comes flooding back online.
And from your perspective, the transition is seamless. You go from a state of total, controlled oblivion right back to consciousness. And thanks to that amnesia switch being flipped, it feels like only a few seconds have passed. It's wild. So the next time you hear about someone going into surgery, you'll know it's not just going to sleep. It's a marvel of pharmacology, a precisely controlled journey into and out of oblivion. It really makes you wonder, doesn't it? Is anesthesia just a temporary, pain-free escape? Or is it maybe the most delicate and incredible balancing act in all of modern medicine?